Welcome to Walkabout the Galaxy, the accidentally educational astronomy podcast where the science is universal, the opinions are personal, and the hosts are remote. We are strange, charmed, top and down the astroquarks, also known as Josh Caldwell,
Addie Dove,
Jim Cooney,
and Audrey Martin.
coming to you from whatever device you happen to be listening to at the moment. Follow us on Instagram and everywhere else we may happen to show up, which is mainly going to be Instagram, where the facts aren't checked and posts cannot be reposted stickily, but in some sort of ephemeral fashion. But they can be liked, so like away and tell your friends to listen to the best podcast. Catch our videos on YouTube. We are at Walkabout the Galaxy, and you can always email us at wtg@ucf.edu. Our stumper today, we have our trivia is going to be kind of up Jim's alley.
Domination.
The stumper is kind of up Audrey and Addie's. So this is about space flight, and the stumpery aspect is kind of weighing how long you want to spend in space, because you have to go to space in this stumper. It's how long you spend in space and where versus like launching. Like, do you want to? Are you a big fan of launching on a rocket? And would you rather do that a bunch of times versus maybe only do that once, but then spend a much longer time in space? So very specifically, your options are you must do one of these three things. Spend 1 year living on the moon in some kind of basic habitat that will, for the sake of argument, we'll say it's kind of like the International Space Station in terms of living space. So, I don't know I don't know how that compares to like a house, but it's probably sort of like a modest single family home space, and there's like you and 6 other people. So you go to the moon for a year. Option 2 is you go to the International Space Station for 1 week, 10 separate times in a year. So it's like kind of monthly trips to the space station for a week. So a lot of launches, but less time away from friends and family. Or 3, the next extreme is weekly launches on the Blue Origin New Shepard suborbital vehicle. So you're launching a lot on a rocket, but it's a 15-minute trip. Got to allow some time to get through TSA and all that stuff, But it's a day at most, maybe a half day, a week for a year. Which of those do you want to do?
one's so hard. I'm really torn between 1 and 2.
Uh-huh.
So
Because you like the rocket launching aspect, right?
no, because I'm actually thinking about it in terms of science. So like one
Nerd.
would be really
Serious of
interesting.
you.
I know, what a nerd. Why would I do that?
That wasn't part of this. Science has nothing to do with this podcast.
Ah, I was spoiled. So I think like the moon one, I would love that one. Yes.
Yeah.
I'm happy. I would be very happy if that is my choice. But the ISS one is interesting because with 10 1-week trips, you could do a science experiment on the first week and then like see what doesn't work, fix it, bring it back, and fly it again in the following week. So you could do
That's very
10 different
professional of you.
experiments. You could do 10 iterations of the experiment, and you could iterate and fix things way better than you could if you like go to the moon and have to either fix things there and you're stuck with what you got.
What about, I noticed that you didn't mention at all the personal impact of being gone and isolated for a year, because you don't get to choose who those other 6 people are.
Yeah, that's fine.
Whatever.
It's a year. Who
That's
even
just a
knows
year.
I don't know. Years
Yeah,
happen.
no big deal.
I mean, yeah.
It's not a dog year,
I actually,
so
the launches. I'm thinking about like going back and forth between like 1G and the 0G on the ISS off and on for a year. That's like really interesting physiologically, I bet, because nobody's ever done that.
yeah.
And also, just like it would be a lot of launches, so that sounds kind of fun, but also more dangerous. Huh?
Right? That's part of the stumper. So
But the
you have to
ISS
make a
is
choice.
leaking right now, so whatever.
Which one are you going for, though? You have to make a decision. You can't just
Should I
say I'm
be should I
torn.
be boring and say one? I'm gonna go two. I'm gonna throw
Two.
everybody off and not go to the moon.
Whoa.
That's cool. 10 trips to the ISS for Addie. Audrey, what are you doing?
Sold.
I guess I'm boring. If I'm gonna do the moon.
No,
Going to the
that's not
moon for a
boring.
year.
Yeah.
Going to the moon for a
Yeah.
That's
year.
awesome.
Mostly because of the launches. I don't want to launch a whole bunch of times. I just want to
Okay.
launch as few times as possible. I never wanted to be an astronaut, but I guess I have to be now.
You do. That's what happens when
And
you come on Walkabout the
yeah,
Galaxy. Right.
yeah,
Yeah.
exactly. And I think it would be better just, yeah, in terms of like gravity to be a year in lunar gravity than have to
Little
go
bit of
back and
gravity.
forth.
Little bit of gravity. You
Yeah,
can actually you can put 1,000 pounds of something of moon dirt on your back so you can
yeah.
walk around and feel like you've got a normal workout going.
Yeah,
All
that's
Yeah.
right.
true. There could be like field trips and stuff as
You just
well,
wear a
which I think
weighted
would be
vest.
fun.
Oh yeah,
Um,
that's
as
true.
opposed to
All
like, I mean, I guess you could go outside the ISS, but like that's not, you don't get to
That's
see
a whole thing.
rocks.
You can
Definitely
take
don't
But
get to
rocks
see
with you to the
rocks.
ISS.
that's true.
Or,
Yeah.
as Addie will say, it's like when she comes back from the ISS, each of those trips, you can walk around and see plenty of rocks here on the Earth. There's no shortage of rocks down here.
True.
We even
Well,
have
I
moon
guess that's
rocks
true.
here.
We do.
All right, Jim, what are you doing?
Yeah, I'm definitely going to the moon. I
Oh, really?
Well, I'm terrified of the launches.
Okay.
I would. I can't go on a roller coaster. You know what I'm saying? The down part, approaching the down part scares me
Oh,
too much.
really?
I can't do it, and it also hurts me. It's like physically. Anyway, I can't do it. So I'm going to the
Go
moon.
on.
I'm going to the moon, and I'm bringing some stamps with me. I'm going to organize them while I'm up there, and I'm going to be good to go.
We're gonna
I'll
put you to
be-
work if you go to the moon. You're not just
Yeah.
gonna be
no,
doing
no.
stamps.
Okay. Interesting. I think I'm doing like Addie. I'm going to the space station 10 times.
We're gonna do so much science. I
Yeah.
think this is partly on my mind because I like talked with a company earlier today who's designing like a next generation space station stuff, and I was thinking
Yeah.
about like all the different opportunities and things like that.
Ooh.
So
Yeah. I don't know. A year on the moon, whew, man, that's just a long time. That's a long
Yeah.
stretch.
a year on the Earth is a long time right now. So, um,
True.
True.
Yeah. But
uh,
there's but I'm not stuck in my house. You know what I'm saying?
no, the ISS
So,
is roughly the size of a 5 to 6 bedroom house.
okay.
Ooh,
Pretty
a big
big.
one.
It's a pretty big house.
Okay.
It's
Good
obviously
deal.
laid out a little differently than typical houses.
Right. Right. Well, today we will talk about the black hole we find ourselves in. Speaking of time feeling like a year feeling like a
Like it's
long
being
time.
dilated.
New observations from JWST, updates from the moon, and much more. But first, this episode of Walkabout the Galaxy is brought to you by spectroscopy. If you
Oh,
need to make sure everything is working fine inside, try an endoscopy, colonoscopy, or cystoscopy. But
Ugh.
if you need some more information about your environment, try spectroscopy. Available since the 17th century, we're constantly adding features to spectroscopy to give you a better view. Less messy than a colonoscopy and less invasive than a laparoscopy, spectroscopy gives you what you want without a fuss. Whether you need to know how fast a star is spinning, the distance to a quasar, or assessing the health of crops, spectroscopy is your one-stop shop to understanding the universe near and far. For a limited time only, mention WTG to get mass spectroscopy at 25% off with your
Ooh.
purchase of any UV visible or IR spectroscopy.
Wow.
Spectroscopy. Fuel exploration and empower curiosity.
Oh.
Exxon?
Intuitive
G-
machines.
GE.
I like it.
Or Caterpillar.
And I'm going to have to start playing the Jeopardy think music for Audrey.
I said Exxon.
Oh, you did?
Yeah.
I thought, I'm sorry. I'm sorry. It's actually
You
Mead.
can still
Mead
play.
telescopes, Mead instruments.
Oh, that
Oh,
makes
nice,
a lot
yeah.
more sense.
Yeah. 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 All right. Space news. Updates from the moon. You're not going there,
I'm
but
not
I
going
guess we'll
there.
let you talk
God.
about it.
Well, I
Ugh.
want to talk about the moon a lot as a main topic more than just space news. But the
Okay.
high level news is that there's a lot going on at the moon, and but there's also a lot going on closer to Earth, right? There's the Butch and Sunny are coming back today.
As we're recording this, they are on their final orbit
Yeah.
and heading towards a splashdown uh, in less than an hour, I believe.
Yeah.
What was their
They're near
total duration?
9 or 10 months, something like that. They went up in June,
Yeah.
I
It's
think.
supposed to be a 1 week stay. It was a Gilligan's Island,
Yes.
real Gilligan's Island situation.
So they're on
Uh,
their safely on their way home,
yeah.
and the I think the last episode that we've had people are going off doing science too much. You guys need to like start slacking off a little bit more.
I know,
Stop
right?
doing all the sciencey stuff. And so we've missed a couple of weeks. But since the last time we recorded, the Intuitive Machines 2 mission, what's the name of the vehicle? Don't know.
The Athena.
Is it the Athena? It's not the
Yeah.
Calypso. Something
No.
called the Calypso that I was reading about. But in
Hmm.
any event, it fell down.
It did. Yeah, so I think the last time we talked in this setting, they had just launched potentially, and we were excited about them landing, and then they did touch down on the surface, and it was not like a crash down per se. They were still receiving data and telemetry, and they communicated with the vehicle when it touched down, but you quickly could tell at landing that it was not a nominal landing. There was telemetry that went a little bit wacky, and then anyway, it was a sideways
And their
landing
power, yeah, I mean, it sounded like from listening to the live stream, it sounded like they could see that their power levels were dropping too fast and not getting
precipitously.
replenished
Yes.
by
Well, they also
this
have
was
like accelerometer data that told them that their main gravitational axis was not in the z
was
direction. It
that's
was
right.
it was in the x or the y, I think. So, um,
Yeah.
yeah. So it tipped over, and it was in a crater. So not only did it tip over just like on the surface, which is bad news in itself because you can't do a lot of the things you're supposed to do if you're supposed to be upright. But it's a deep thought for everyone there. But also because it was tipped over and into a crater that was a kind of a dark crater, it just it wasn't getting sun like at all on
Sunlight.
its solar panels.
This
So
Oh
that's
this
why
is
it
the
had a
no.
very, very
southernmost
short mission.
the southernmost landing ever on the moon.
Yes. Yeah.
Further south than their
Oh.
last one, which
Literally where
also
the
fell
sun don't
over.
shine.
Right. So if you're
Are
in a
they in
hole,
a permanently shadowed crater, or is it?
I mean,
It's
if
not,
you're
I
near
don't
the
think it's a
pole,
permanently shadowed crater, but it's a very high amount of time shadowed crater.
Hmm.
yeah. I mean, it's not very big. Like it kind of looks like it would be hard to manage to hit that crater. Like
Yeah.
it's just slightly bigger than their spacecraft. It's like perfect
Well,
size to
Oh.
like pack
Which
that
I guess,
spacecraft and
yeah.
lay it on its side inside that crater. And then if you think
but
about
there's
it
a lot of those
that way,
craters. So,
that's true.
And it's harder to, I guess, locate the smaller craters. If it's a bigger crater, then you can identify it like when you're at a
Yeah.
higher
orbital. Yeah.
I mean,
altitude.
this is why these, one of the reasons these landings are so hard is the vehicles have to be able to really figure out what is the surface like underneath them while they are landing,
Yeah.
and then make adjustments accordingly. And that's super hard
Yeah. It turns
because
out there's a lot of dust.
Hmm.
you're kicking up dust with your engines. If
Yep.
you're in a polar region, you've got all kinds of crazy shadows being cast. So normal imaging, like just taking a
It's
picture,
challenging.
is
Oh.
very difficult to interpret what you're actually over. So you need to have what they use LiDAR, I guess, laser ranging, and but dust
Yeah.
can interfere with that. So yeah,
Yep.
Oh, was it the dust? Is that what the issue was?
I don't
I mean,
know.
Or
they haven't
we
fully
don't know what
said,
the
but
issue is?
they do have challenges with their LiDAR system that have to do with dust. And they had some challenges with their imaging system also because of that, right? Because you have to be able to
Yeah.
have like pre-dust images that you're interpolating from, I think. And I think that they've had challenges with that system.
Right. Yeah.
But they didn't quite land at their landing site, and the
They're a
engine
couple
stayed
hundred
on longer
meters
than they
off.
wanted to. So, yeah.
Oh.
Yeah.
Oh, that's not good.
Yeah. So
Do they have
Anyway.
another? Is there an IM? This was IM2, right?
Yeah.
IM3
Is there
is in the books. Yeah,
IM3
scheduled.
is scheduled, yes.
Fingers crossed.
Intuitive
It's
machines
Supposed
for
to be
next year sometime.
2026, but that might slip slightly depending on
Okay.
Right.
anomaly investigation, like depending on investigations, and if they figure out that's for some stuff they can do to like improve the outcome next time.
Yeah. Other space news? You want to just then transition straight into moon science?
Yeah. Yeah. So the other lunar lander that landed more successfully, um, and actually operated for like almost the whole lunar day was the Blue Ghost 1 landing. So this is by the company Firefly, which you should love, Jim.
Such a good show. Such a good mission.
So some of
Sorry,
their
I feel really stupid for not making the connection there. I'm
I
like,
didn't make the
and it's
connection
because
either.
it's actual like insect firefly season here. And
Mhm.
so when he said that, I'm like, I know Jim likes Scrabble, and I
So
know
if
he
you look
likes
at the company
stamps,
though,
and I
some of
know he
their
likes
early stuff.
fishing. Does he
Mhm.
also like fireflies?
Of
They
course, who
are
doesn't
pretty
like
cool.
fireflies? Do you
But
call them fireflies or do you call them a different name?
I call them
Lightning
I
bugs?
call
fireflies.
them fireflies. I'm aware of
Okay.
another different name. What do you call them, Jim?
Yeah.
I call them fireflies, but lightning bugs is
Okay.
good too. Yeah.
Yeah, yeah, okay.
But they're cute. They're wonderful. They're great.
They are.
But the show is
Uh,
fantastic. And the mission. Tell us about the mission. I don't understand what's
well,
happening with the mission,
but
but I'm excited.
a few of the things from that company are named after things in the show also.
Oh, I now love
Yeah,
this. I love it so much
yeah.
more.
Oh.
They have a
Oh.
Miranda engine,
Oh.
and a couple of other things. Yeah, but
So
mostly they're trying to
just
go with things from the bug.
just in case people aren't familiar with what we're talking about
I didn't
we're
think Jim
talking
was going to have a breakdown.
we're talking about
Wow.
the
Who
short-lived
knew?
sci-fi series Firefly that
Okay, go
starring
ahead.
Nathan Fillion. There were 13 episodes. What is it, like 20 years ago or something? And then
Oh
they did
God.
make one movie,
Yeah.
Yeah.
Serenity, which
Serenity.
was
Yep.
good.
Serenity. Yeah.
Yep.
And just I'm
So,
sorry, Addie.
no, it's fine.
Cannot talk about science. Can't talk about lunar science and stuff. Um, I just have to mention that I had an interesting conversation with a colleague today who told me that he told me the following things. Reconcile this and see if your brain explodes like mine did. Uh, He says, I love science fiction. I love fantasy. I have never seen any Star Trek. I have never seen any Star Wars.
Sounds like
Interesting.
a liar.
That is very bizarre. That is very
He's like,
bizarre.
I don't
So,
do mainstream sci-fi
Yeah.
and fantasy.
yeah. So, anyway,
Yeah, what kind of
Interesting.
sci-fi and fantasy is this person into?
well,
Not
anyway,
Firefly, maybe.
I'm talking
So
about
back to
Firefly. I was just like,
maybe
made me think of
Firefly.
that.
Yeah.
Maybe
So this mission so it just ended actually. The mission just ended a day-ish ago. They had a
on
press
schedule.
conference
Oh.
today on schedule. Yes, on schedule. They had a press conference with NASA today. And this
So
mission
first
was
of all,
super
who is
exciting.
this? Who is this doing this?
So this is a company called Firefly.
Okay, I thought the
Firefly.
mission was called Firefly.
Jen, you'll love that.
No, the company is. Oh my God. The company is called Firefly. The mission was called. The lander was called Blue Ghost, and so this is Blue
Okay.
Ghost Mission 1. And they it was a lander. If you think about like an Apollo lander, kind of looks like that. A little bit littler, I think. And it had like 10 NASA payloads on it, and then also some commercial ventures. Like there was some communication stuff on there. And it's been super exciting over the past 2 weeks. So it was basically a 2 week mission because that's the length of a lunar day. So sunrise to sunset on the moon is about 2 weeks, about 14 days. So nominal missions right now are about 10 days if they're going to be while there's sunlight in that area. So they landed pretty early in the lunar day, which means it was kind of dark still when they were landing. There was still a lot of shadows. And so, they actually were able to see sort of sunset over a local feature, and then they just posted some photos of sunrise over some local areas, and then they just posted a picture of sunset, Josh. Like they were getting some sunset images, so we might be
Yeah.
able to look for some horizon glow type things.
Cool.
Didn't they
Um,
also get a time lapse of the lunar eclipse? Did you already say that?
I didn't say that, but
Okay,
yes, in the
yeah.
middle of the mission was when we
Way
had
to
or
steal
toward the
Addie's
end.
thunder, Audrey.
No, it's great. It's everybody's thunder. We're all so excited.
Yeah.
They were on the moon during the eclipse. And so when you're on the moon during the eclipse, it's a solar eclipse. Because
Yeah.
it's the Earth blocking the sun. Crazy. And they got that, and it's super cool.
Yeah. which is yeah, and there's I have seen a couple images, and so obviously some differences. When we see a solar eclipse, the moon that's blocking the sun doesn't have any atmosphere, whereas the Earth has an atmosphere which refracts sunlight through it, and so there were some pretty interesting, pretty comma
Yeah.
interesting glows of
Yeah.
through the atmosphere around. And all the other
And
is from our perspective, the moon is just the same size as the sun, but the Earth is much bigger than the sun if you're on the moon.
hmm
And so it's a different kind
like
of covering
totally.
up.
Yeah. Yeah, and the other thing is if you were watching, I'm a terrible lunar scientist and I didn't get up to watch the lunar eclipse this
Yeah,
last
me
week.
neither.
It was at like 2:30 a.m.
I
and
was
I
awoken by
just
my screaming child, but at the
Oh,
perfect time.
perfect.
It was like totality or whatever.
Oh,
It was perfect.
Oh,
Yes.
really?
That's
Yeah.
why he was screaming. He's
Did
like,
you
"Why is
did you
it red?"
Maybe.
did you drag him out into the frigid winter snow and say,
We
"Here,
did. We
screaming
did.
kid,
We
look at
did.
that"?
Yeah,
good.
That's what you
That's
get.
good.
that's
But
right.
so if you observed it, Jim, what color was it?
It was orangey.
Yeah, it was reddish, and that has to
Right.
do with what you were just talking about, Josh, right? Like light scattering, things like that. So for us, the moon sort of appears reddish, orangey during the eclipse, but also from the surface, one of the cool things was that like the lander and sort of the surroundings looked redder to the cameras uh,
Right.
during the eclipse, which was
They're
super
getting
cool.
all that red light through the Earth's atmosphere.
Yeah.
Yeah, cool.
That's awesome.
Yeah, so that was things that were happening while it was on the surface. So there were like 10 experiments on the lander, and I think we've seen data from almost, or operations from almost all of them now. They've been putting out little bits and pieces. A bunch of them were looking at dust stuff that are relevant to things I'm interested in. They've released really cool images from there's the lander cameras, but then there are also a camera instrument suite called SCALPS, which is an acronym, stereo cameras for lunar plume surface studies. That
They had
got
like a
high resolution and four different cameras with different focal lengths, and to do like sort of movies, but they're like 5 frame per second kind of thing, of the landing, and that was really cool.
they also had like a jackhammer drill thingy into
Yeah,
the
there's a
lunar
thing called
surface.
LISTER, the lunar instrumentation for subsurface thermal exploration with rapidity.
Yeah.
But it's a
With
pneumatic
rapidity. Yeah.
with rapidity. So it's a pneumatic probe, so it's actually blowing air down into a little hole to make space
And
to drill
Ooh.
blasting stuff
down.
out. Yeah.
So some of the images from that are pretty crazy because you get these little like bursts of air coming out and
They
dust and
had,
stuff.
isn't this the one that had the electrostatic dust cleanser
It does the EDS, the electrostatic dust S shield. There we go.
system or something? Yeah.
Yeah, a shield. So that's the idea that you can do a little like square wave on a surface. You have little built-in electrodes, and you put a little wave of electricity across it, and it makes like a traveling wave that clears dust off. And so they got to demonstrate that a few times. There's lots of thoughts to put that on like solar panels or instruments or other things. There was
Let me, yeah, I don't want to stop you, but I have a question, a
bunch of
general
other instruments
question.
also.
Okay.
Go ahead.
I didn't mean to cut you off. But my general question is, just gets back to this thing where, and there have been many missions like this to the moon. As you mentioned, you land sort of early morning if you can.
There haven't been that
And,
many.
well, okay, however many there have been,
Okay.
regardless of the number there have been,
Yes.
the profile and the profile for your LunarVise mission is also following this, which
hmm
is land in the morning, kind of
Yep.
as early as you can, and you're
Yep.
using solar power and you're enjoying the nice daytime temperatures. And your operation time is, 10 days, 12 days, 14 days at the outermost. And then you're dead. That's the end of the
hmm
mission. And it costs money to build a spacecraft and launch it and get it to the moon. It almost seems like they're saying it costs less money to do that than it does just to keep something alive for 2 weeks in the night,
Sure.
like in the lunar night, so that because 2 weeks later, after the sun sets, the sun also rises.
It
You can
does.
quote me on that.
You can quote.
And when it comes
So,
back up again, it's going to be warm. You're going to get solar power again. I'm like,
yeah.
why aren't we doing
Good
Months
question, Josh. I
long.
like that. I like that question. I had the same
So
question.
there's very much interest in that. And obviously a lot of these people who are building these landers now are companies, right? So they're very interested in what's
Keeping
going to
things
last
going.
longer, how can we drive costs down, how can we keep going, and things like that, right? So one of the next landers does have survive the night capabilities. It's going to try it. Um, so
A
the big
sleepover.
thing on the moon is that it gets really hot during the day. And actually, that 10-day mission during local noon, it shut down. And they were just like trying to keep everything cool enough to not
Jeez.
have bad things happen.
I was
Oh
actually going to
Like
wow.
it
ask that
gets
too because it's
so
something like
hot.
300 degrees on the surface or something like that, right?
So hot.
Three
Yeah. Yeah.
Fahrenheit. I mean, yeah.
Yeah, so they have radiators, they try to cool, but like it just gets really, really hot. And this is something like we're concerned about for our cameras too. So there's a couple days in the middle there where you're also not doing any operations. You're just trying to survive, typically. And then, well, typically there's been like one really that's done it now, but there's been a couple of others. So the Japanese Slim mission did survive the night 3 times, I think. So it went to
Oh,
sleep
Ooh.
and woke up 3 times where it
okay.
had so the big issue at night is that it's very, very cold, and so you have to have electronics that can survive those really cold temperatures, and that's the big challenge. Is like you're not going to probably move around a lot, so you don't need to worry as much about mechanical things as long as you can warm them up again, but like electronics just
Mhm.
surviving the cold is really hard. And so, but there is a lot of tech development being done, and a lot of the companies are looking at ways to how they can insulate better or how they can have heating sources and things like that that
Yeah,
can
get those things like when you
um,
go skiing, you
yeah,
open
just
them
little
up, you
hand
put them in your
warmers.
gloves, your socks, things like that.
Yeah. Yeah.
Did the
So
did the
that's definitely of
Chinese
interest. And there are upcoming missions that are supposed to be able to do operations into the night and potentially survive the night. And somebody
did the
asked on a press
Chinese
conference
ones
about the
survive?
Firefly one today, and they said, we don't think we will, but if we did, that'd be awesome. So
Okay.
the
All right.
Chinese, so the
Like the
U2 rover has
Chang'e,
had like, yeah, because the U2 rover even has had multiple months,
multiple, right.
years
Yeah.
Yeah.
maybe at this point of operations. So, like, yeah,
Okay.
those have
Yeah, we
survived.
got to get on that. We got to get on that. Um, well, we're going to transition to Jim's topic, which is black holes. What else? We have a black hole trivia. So let me give you
Ooh.
your black hole trivia. It's just basic trivia, nothing complicated or fancy. Um, Giving Jim a break from rocket launch trivia, and it's a simple three-parter.
Sure.
Is it three parts? I think. How many black holes have been identified in the Milky Way galaxy? How many stellar type black holes, stellar mass black holes, do we think there are in the Milky Way galaxy?
Oh,
And how close is the nearest black hole to the Earth? Clearest known. There could be others that we haven't seen, but how close is the nearest black hole that has been detected to the Earth? Obviously, for the first two, you know, there's a little bit of wiggle room in your numbers because the second one's an estimate for how many total there are in the galaxy. And the first one, even the first one's like black holes, it's kind of like exoplanets. You've got a candidate, and then you have increasing confidence that that's what it is based on the measurements that you've got, but not always do you have like 100% certainty. So a little bit of wiggle room for both of those first two, not for the third one. Okay. So with that lead in, Jim, do you have some black hole news for us?
Dude, dude,
drop some black hole knowledge.
what if we live in a black hole? What if our entire observable universe is inside of a black hole?
I thought it
Sounds
was.
it sounds like a drug fueled thought.
It does. It does. It sounds like shrooms have been on the menu.
Shouldn't we be falling
Yeah.
towards the singularity or something?
Yeah. So,
Shouldn't we be spaghetti?
well, no.
Oh. Okay.
Um,
Well,
I mean, this idea.
Identification
Explain
is
what
more
you
of a.
mean.
So I'm going to explain what I mean. I'm going to explain what I mean, and I'm going to tell you why I'm thinking about why we're talking about it today. Because there's been kind of some new measurements, JWST measurements, that are telling us something interesting about this. So people have had this idea for a while that maybe you form a black hole when a star collapses, and the material collapses down, and of course in the original Schwarzschild version of a black hole, all the stuff collapses down to like infinitesimally small, right? There's to a single point called the singularity. We know that there's trouble with that, right? Because quantum physics doesn't like that. And there are other
Nobody likes that. Nobody likes singularities.
No,
even
Einstein
classical.
did.
Really? Did he like it?
I don't know. Maybe he did. Maybe he didn't. I don't know. It is troublesome. But we get out of that trouble by modifying general relativity just a little bit, and basically allowing for the spinning of space-time. And anyway, one thing that would happen for a typical black hole that is spinning, which of course almost every star, I mean all stars are spinning to some degree, right? And as they collapse down, they're going to spin more and more. So they have some angular momentum associated with them. The material that's collapsing down has some angular momentum associated with it. And so as it gets really, really, really small, if I have this kind of alternate versions of GR, it doesn't actually go out all the way down to a singularity. It collapses down to some really, really, really crazy hot, dense state, and then bounces. And that bounce,
Big Bang,
looks like a little bit like a Big Bang. And it could be that our entire observable universe is the result of one of those bounces of a larger parent universe, right? So we're in a black hole in a parent universe, and
Look at why we're in a black hole in this metaphor.
yeah. Why do we have to be in a black hole?
we don't have to be in a black hole.
It
This is just
works out that we could be.
we could be, right? So this you can work out the math of general relativity, and
I can't.
in this kind of a scenario, I know I can't either, but in this kind of scenario, you'll end up with a thing that looks like our universe in many respects, but there are a few little differences. Like in this version of the universe, it came from a spinning thing, and so there's some net angular momentum to the universe.
Oh,
Right.
okay.
So that's a thing we could look for, right? So if we go out and look in the universe and see that it has some net angular momentum, some preferred direction, that's going to be interesting.
How do we look for that?
So here's one cool way you could do is go look at a whole crap ton of spiral galaxies, because they're all
A
spinning,
metric
right?
crap ton.
Right.
And see if, I mean, you would expect, if the universe does not have any preferred direction, that if you looked at enough of them, their directions are all just kind of random.
Kind of like chirality. Okay.
Right. So if you looked at it, like if you call the Milky Way, if you say it's rotating counterclockwise because you're looking at it from whatever, then if I look at 1,000 galaxies, then roughly 500 of them should also be spinning clockwise or counterclockwise, and the other counterclockwise. Some recent,
They should be in all sorts of weird orientations and stuff.
right. Weird orientations, but if you like, let's call everything that's,
Sure.
on our half of the thing clockwise and the other half counterclockwise.
Yeah.
I have an objection to raise to this, but carry on.
Okay.
Oh.
I'll hear your objection in a minute. So one thing to do is look at these galaxies and look at this rotation. And so you can do that. James Webb is letting us do that for galaxies that are even more distant than we have been able to do that before.
Right.
And so a recent publication has seems to be showing that 2/3 of galaxies are the opposite direction of the Milky Way, and only 1/3 the same direction as the Milky Way, which would be
That's pretty.
very interesting.
I'm still gonna raise my objection, but that's pretty cool.
Does that depend on like where you set where that split dividing line is though?
No, I mean that that indicates a preferred direction. No matter where you put your thing, if you put it the other way,
I just don't understand how you decide what's up and down in this version.
You just make some arbitrary decision.
A plane arbitrarily.
Right, you draw a plane arbitrarily, and
you put an arbitrary plane, and then any arrow that's pointing up from the plane gets a 1, and every arrow pointing down from the plane gets a -1. And you add all that up, and it should add up to 0.
Of where you arbitrarily draw that line?
And it should be independent of
where
that...
Is it?
Right. I mean, that's something they would need to... That would depend on if
they probably checked that.
So what's the number of galaxies they're looking at?
Their sample size is not that huge. It's 300 or 400.
Okay, because if the sample size were 6, Addie's question would be incredibly
Right.
on point,
Right. Right.
because then it is going to matter where you could choose it so that you could get 5 and 1 or 4 and 2
Right. Right.
or 3 and 3. The bigger that n gets, the harder it is to do that.
That's right. No, yeah, and
Um,
no, there should be. I mean, if your sample size is 300 or 400 galaxies, there should be no plane that you can draw where you're going to get any substantial difference from roughly 50-50. And
right.
having 2/3, 1/3. I mean, we arbitrarily chose the plane as the plane of our galaxy, but it's that's irrelevant, right? If it's 2/3, 1/3, that
Right.
means there's something
If
off.
there's 300 galaxies, you should not be able to choose any plane
That's right.
that has 2/3 in one half and 1/3 in the other
Sure.
half.
That's
So,
correct.
so at some very high level of probability. My objection, are you ready to hear my objection, Your
I'm
Honor?
so ready.
Yes.
My objection is I would think that the dominant portion of angular momentum of the universe would not have anything to do with the angular momentum of spiral galaxies, which have a
I'm
tiny, tiny
wondering about
fraction
that.
of the mass, and the angular momentum depends on distance, a lever arm, a distance from a spin axis.
Mhm.
The angular momentum of the solar system is not in the sun.
That's absolutely true. But if you
It's in
look at our
Jupiter.
solar, like, right, 100%, that's absolutely true. Most of the angular momentum of the universe is going to be in gross motions of big piles of dark matter.
Right.
However, if you look at our solar system, not all, but the majority of the bigger objects spin in the same direction as
True.
everything orbits, right? Which
Is that your final ruling?
what I'm saying is the small bits will not in toto, but on average, small bits will go the same
Go with the
direction as
flow.
everything, right? And so
Okay.
this isn't the most fundamental way of measuring it, but it's a way. It's an easier way because measuring how dark matter is moving, finding out where it is and kind of mapping it out is
Right.
a doable-ish thing. Finding out what direction it's going is considerably
A lot
more
harder.
difficult. Because
That's
it doesn't,
pretty cool.
So,
That sounds
anyway,
like-
That's fun.
I'm kind of-
What would it look like from the outside? Like, I'm just imagining a black hole in our universe with
Right.
another universe inside of it.
right? This
How-
raises
like, how
the
is-
possibility
this
that
doesn't make any
that's happening,
sense.
right? That
Well,
it's
Yeah.
turtles all the way down?
yes, it absolutely raises that
Oh my
possibility.
God,
That
it's black
every
holes
black
all
hole
the way
in
down.
our
Is-
is
yeah,
birthing a new
like-
universe. You can't tell. You don't know because remember
This
the
is
awesome
a
thing
great
about black
sci-fi
holes
concept.
is that you can't get any information out of them, right? So it's not like
Right.
if that's happening with the black holes in our universe, we're not going to know because
But
until
when
you
the
go
bounce
into one, right?
happens, when the
Well,
bounce
so-
happens, like how does that? What is that even even like?
So
inside of
I
a
know
black
it's weird
hole?
because like if there's a black hole in our galaxy that's stellar mass, it has a size that's whatever 20 kilometers or whatever
Yeah.
3
Not
kilometers, something like that. But coordinates inside of a black hole and coordinates outside of a black hole are not the same thing. It's like that r, the distance from the center, don't mean the same thing. So you could conceivably have drastically more space inside of the black hole than you do outside of the black hole. Outside, it looks like a sphere that's 3 kilometers in radius. Inside, it's a universe. This is not an impossible thing.
That was wild.
That's like
So-
the Doctor
Okay.
Who thing or whatever.
Understand why it's
Okay.
a black hole still.
So let's say, okay, let's take this thing. We're inside a black hole. What, like, I don't know. We have this cartoonish notion of a black hole
Don't
is
tell Brandon.
there's an event horizon.
Yeah,
Inside the event horizon, every trajectory
correct.
of everything goes
Yeah.
to the singularity at the
Right.
center.
Right.
So everything is heading that way. Like,
Right.
what are we?
So-
Where are we in this black
So-
hole? Are we in the space in between some singular, or we're part of?
Yes.
I don't.
We're
I
not
don't get
right.
it.
So for one, these rotating things, there isn't exactly one point singularity, but it is still true that we still have trajectories that are going to take us towards the center, but they don't have to immediately take you to the center, right? We're in the expanding portion of this. So
Yeah.
the thing collapsed down, it's blowing out. That eventually we're going to end up back at the singularity, but that doesn't have to be tomorrow or a billion years from now or 10 billion years. It can be whenever. So,
Okay. So another way to turn this around would be to say that inside black holes, there could be all sorts of cool, interesting things going on.
yeah, there could be.
It's not just like empty space and a little
No, I mean there definitely are. You can exist inside a black hole and not be in the singularity for a while. It just depends on
Yes.
what your projector. You're going to eventually end up at the singularity, but it doesn't mean instantly you're there.
Yeah.
Um, and
I definitely
especially in
feel like
rotating
I'm on
black
my way to the
holes.
singularity. I can tell you.
Yeah. So a lot of this is just we don't really understand what the hell's going on in a black hole. There's a lot of ambiguity about what all the coordinates mean and all that kind of stuff, which means we can get a little bit nuts with
We can get
these
carried away.
Is
ideas.
this
Yeah.
but I feel like this version changes, to Josh's point, I feel like this version changes what it means to be a black hole. I don't know.
Yeah.
Well, it's just from the outside, a
Because if a
black hole
whole
is a fairly
universe
simple
can
thing
be
to think of. It's like everything's just in there, and you can't get any
Sure.
information out. But when you're in there, it is a very different story, right? And it's
Yeah.
weird, and who knows what the hell's
Okay.
going on in there.
Okay.
All right.
This is like that
Great.
one Rick and Morty episode.
But to be
Where
clear,
Rick
this is
designs
a
an
little bit
engine.
of we're being a little bit, the more likely scenario is that
Or
that's
likely
not
scenario is this is a hologram.
right. No, the more likely scenario is
The Earth
that
is flat.
that we did not do a good job of measuring these things, and that there
The
are
rotation.
there have been other
Oh.
studies done with other galaxy samples in the past
Hmm.
decade or two that have said it does
isotropic.
average to zero, right?
Okay.
This is a little bit
I was
better
getting
one
excited there.
because it's deeper. It's James Webb, but it's intriguing, but it needs a lot more clarification. We need
Yeah.
to
More
look at more
data.
than that one little part of it. They looked at all little patch that's contained inside of the Hubble Ultra Deep Field and that little patch of sky. We need to look at a bunch of
Oh.
different directions.
Uh-huh.
Because
Yeah.
it's also possible in that one area of the
Something
universe, there's some weird anisotropy or something. So we need to look more. But if it turns out to be robust, it's really, really intriguing because
Yeah.
you can explain it in other ways, but the black hole thing is kind of the best that we have so far. Anyway, something to think
All right.
about.
Before I quiz you on your black hole trivia questions, Audrey had a asteroid moon linker story.
Yeah. Yeah. There was an asteroid that was talked about kind of a lot in December-ish.
I think we talked
I
about
was
it.
talking about
Yeah,
it
I
a
think
lot
we
in
talked about it.
December.
Yeah.
We did.
I'm still talking about it.
2024 PT5.
PT5.
Good old PT5.
We
Yeah,
love
PT5.
PT5. But it was called the mini moon or the quasi moon. It was the one.
It was
It
basically one of
basically
these
has
newer
a
mini moons.
Yeah, exactly. It has a very Earth-like orbit. So it orbits. It's a near-Earth asteroid, an NEA that orbits all very closely matches the orbit of Earth. And the question is, for a lot of these near-Earth asteroids, where do they come from, and why are they in near-Earth space? And the more we know about them, the more we can look for potentially hazardous objects and different orbital spaces and things like that. And so there was a team that looked at its dynamics and its spectra, and they looked at the spectra of this object in the invisible and near infrared, which
They
is
did
the
some
same wavelength
spectroscopy?
region. They did some spectroscopy.
Wow.
Yay!
I know, it's so great.
Thanks.
And this is a wavelength range that is very common for a lot of asteroids. So we have a lot of asteroid data in this wavelength range, and they compared it to a whole bunch of asteroids, and it really doesn't look like any of them. So they compared it to the moon, and its spectra looks a lot like the lunar highlands,
Wow.
which is
That's pretty cool.
kind of uncommon for an asteroid. And so then they did the dynamics, and it works that at some point in its past, it kind of meets up with the moon. So this object could have come from the moon during some cataclysmic cratering event. There was also another asteroid that was discovered a while ago, and then they kind of did the same thing, and I'm trying to find the name of it. It has a very Hawaiian name, so even if I find it, I probably won't be able to say it.
So I
correctly.
think we mentioned this possibility. I don't know if it was for
Yeah.
this one or another one.
I think it was this one.
Also, might have
Yeah.
been this one.
Because dynamically, it seemed like there are some folks that did dynamics and said
dynamically,
it could
they
have
had connected it.
come from the moon or something too.
Yeah, so
Yeah.
now we've got a compositional link as well as a dynamical link.
Yeah,
So-
yeah.
Cool.
The other object is Kamo Oa Lewa. I'm probably saying that wrong. But yeah, so there's this compositional link between both of them and also the dynamical link. And just from looking in the like database of objects in around Earth and the moon, it seems that there's potentially about 16 total objects that may have come from the moon, which is really exciting. Yeah.
Do we
That
know
is
like
exciting.
how recently they were knocked off the moon? Are we talking a million years, a billion years, 1,000 years?
No, I don't know, but the other object, the one that I can't pronounce, is probably older because it has a redder spectral slope, which is
Space weathering.
typically associated with space weathering. So it's been exposed to space for longer. But dynamically, I'm not sure. I'm not sure what that is, but potentially there's way more than 16. These are just 16 that have been found
Sure.
we have like orbits for them and everything. But yeah, we might find even more.
Speaking of things we might find more of, how many black holes do we have a pretty solid feeling that we have identified in the Milky Way galaxy? And then how many more do we think there actually are? The first two pieces of your trivia. Jim, should we make you go first?
I don't even feel like I know order of
I think we
magnitude for
need.
this one, and
I
I
think we
should.
I
need.
don't either.
I don't know.
I
Either,
had
but
no
I'm
idea.
going to say I think we know of 70, and there are 10
Okay.
million.
70 and 10
Wow.
million. Okay.
My gut was saying 100, so I feel like I'm not far away from Jim. So
Yeah. Okay.
yeah, 100, and there are. What did you say, Jim?
10
We
million.
said 10 million.
And there are a billion.
Okay. Addie?
I'm going to say 300 and
Okay.
5 million.
Okay. So something on the order of probably 15 to 50 that we know of, depending on who you
Whoa.
ask and when you're. So
That's so few.
Jim gets that one with a low guess in terms of identified stellar mass black holes in the galaxy, and I'm going to give it to Audrey for the estimate of how many we think there are. Those numbers sort of range from 100 million to a billion. So it's just based on stellar evolution, right? It's like population of big stars, how many of them have popped off, over the past 12 billion years, and what fraction should leave a black hole behind. Yeah. And your final part of the trivia was, how close is the nearest known black hole to the Earth?
15 light years.
15 light years, says Jim.
I feel like we talked about this and I don't remember. I feel like Jim should know it though.
I should know it, but I don't. So I'm going with 15.
Wait, is this closest stellar mass or closest at all?
Any mass.
Closest at all.
The stellar mass one's
But
going
I'll
to be a
give
lot
you a
closer
hint.
than
It is stellar mass.
Yeah.
Okay.
Because the closest non-stellar mass is at the center of the galaxy, and it's closer than that. So that's your hint.
Great.
100 light years.
15 light years, 100 light years in the upper right corner, upper left corner of my remote
7
window.
light years.
7. Wow. It's interesting. I'm curious to hear the reasoning, and I had no idea until I looked it up. 1,560 light years.
Oh, wow.
Wow. Okay.
Is the closest. And it's basically, we don't see these because they're close, right?
Yeah.
We see them because of weird things that they're doing to stuff around them, which is usually energetic enough that we can see it from a greater distance. And in fact, this black hole is called Gaia BH1. I think BH might stand for black hole even. Maybe.
Oh, clever.
Okay.
And if you remember, Gaia is an astrometric space telescope. So it's measuring the positions of things very carefully. And so it could measure, so it does depend. I mean, it did need to be kind of close, but it was measuring the very high speed of things in the neighborhood.
Oh. I did not know that. That's fun. I would have guessed it was one of these X-ray binaries like Cygnus X1 or something, which I thought was a lot closer, but I was clearly is not.
Geez, Jim.
It's speaking of nearby black holes that aren't stellar mass. there a new paper out saying that the Large Magellanic Cloud may have a supermassive black hole in it of about
Oh,
600,000 times the mass of the sun,
yeah.
determined by scattering stars and things like
Wow.
that. Yeah, cool.
Splashdown!
Woohoo!
Butch and Suni are back.
Yay!
Good for them.
And on that
Amazing.
note, while it may have felt like falling over in a lunar crater, it was just
Aw.
another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Rusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in New York and around the world, I'm Josh Caldwell.
I'm Audrey Martin.
I'm Addie Dove.
And I'm Jim Cooney. We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.
Yay!
Pop, pop.